Hey everyone, welcome back to the DevOps course. I'm Saba and today we're stepping into the world of Linux. Whether you're coming from Windows, Mac OS or are totally new to operating systems, this lecture will give you a solid foundation of what Linux actually is, how it works and why it's everywhere in DevOps. Linux is one of the most important things you'll learn on your journey. While you might not manage physical servers day to day, having a solid grasp of system administration fundamentals is essential in DevOps. You need to understand how Linux works, how to navigate it, and how it fits into everything from Docker to cloud servers. Let's dive right in. Before we jump into terminals and commands, let's take a step back. Linux is an operating system, but more specifically it's a kernel that powers a huge variety of systems around the world. From servers to smartphones, smart TVs to containers, Linux is everywhere. But here's the thing, when most people say Linux, they're usually referring to a Linux-based operating system, which includes the kernel and collection of utilities, tools, and libraries that work together to make your computer function. Linux is known for being open source, which means its code is freely available for anyone to inspect, modify, and distribute. This openness is a big reason why Linux has become so dominant in the server and DevOps world. It's also incredibly flexible. You can build a full desktop OS with Linux or strip it down to run on a tiny device. That flexibility is why it's used in everything from data centers to cars, drones, satellites, and even your Wi-Fi router. Linux is modular, efficient, and built around the philosophy of small programs that do one thing well. This design makes it easy to customize, script, and automate, which is exactly what we love in DevOps. So when we say Linux is everywhere, we mean it, and it's worth understanding why it's so widely adopted. Let's rewind the clock a bit. In the 1970s, Unix was developed, a powerful multi-user operating system. It inspired many others, including the GNU project in 1980s, which aimed to build a free Unix-like operating system. GNU provided tools like compilers, shells, and utilities, well, basically everything except the kernel. In 1991, a Finnish student named Linus Torvalds released the Linux kernel as a hobby project. He posted about it on an internet forum, offering it freely to anyone interested. That kernel, combined with GNU tools, became what we now call Linux. It's all around us, whether you see it or not. It powers most of the internet's servers. Think Google, Facebook, or Netflix. Every Android phone, routers, switches, smart TVs, cars, even spacecraft. Linux is the default OS for cloud providers like AWS and GCP. Even Mac OS has a Unix-like foundation, so if you're on a Mac, you're already working in an environment that behaves similarly to Linux. Many DevOps tools are most commonly run in Linux-based environments, so whether you're deploying code, troubleshooting an issue, or provisioning infrastructure, chances are you're doing it on Linux. That's why understanding Linux is essential. It's the foundation of the modern infrastructure stack. Let's take a step back and talk about the operating system itself. An operating system, or OS, is the layer of software that sits between your applications and your computer's hardware. It handles things like managing memory and CPU resources, running programs, handling input-output operations, managing file systems, and security. You can think of it as the traffic controller for everything that happens on your computer. The OS provides the environment for your programs to run in. It's what decides what runs, when, and how, and it interacts with your system. Now, inside every OS, there is a core component called the kernel. It's like the heart of the system, and we will talk about it next. But before that, here's the key takeaway. Your apps don't talk directly to hardware, they talk to the OS. The OS talks to the kernel, and the kernel talks to the hardware, and that's the world Linux lives in. Let's break this down further. Linux systems are divided in two major areas, kernel space and user space. Kernel space is where the low-level system code runs. This includes memory management, process scheduling, file systems, and device drivers. User space is where your apps, scripts, terminals, and services run. The two communicate using system calls. When a user space program wants to do something privileged, like read a file or open a network socket, it requests it through the kernel. This separation is critical for security and stability. If every user application had a direct access to hardware, a single buggy program could crash the entire system. By keeping user applications isolated and requiring them to ask the kernel for access, Linux protects the system from accidental or malicious behavior. It also allows the operating system to manage permissions and access control, ensuring that programs only do what they're allowed to. This clear boundary between kernel and user space is one of the reasons Linux is known for its modular design and resilience. Now let's talk about how Linux organizes files. Unlike Windows, Linux doesn't have drive letters like C, for example. Everything starts from a single root directory, and everything else branches from there. Let's walk through the most important directories so that you can understand how the system is laid out. We will start with home. This is where user directories live. When you log into a Linux system as a regular user, you're dropped into your home folder. If your user is called Saba, then your home directory would be /home/Saba, for example. It's where you store personal files, downloads, and configs, similar to My Documents in Windows. Then there's etc. Some people also like to call it etc. This is where all major services like networking, user accounts, cron jobs, and more keep their config files. We also have bin and sbin. These contain essential libraries, executables if you may. Think of bin as folder containing user level commands and sbin system commands like shutdown or reboot and so on. In var, which stands for variable, we hold log files, temporary state, cached package downloads, and more. It's one of the few folders where data is expected to change often. There's also user. Despite the name, user doesn't mean the user. It's more like Unix system resources. You'll find user space apps here and their libraries. It's mainly used for installed packages and documentation. Now here's a fun fact about Linux. In Linux, everything is a file. This isn't just a fun saying, it's a design philosophy. In Linux, your hard drive, it's a file under /dev directory. Your keyboard, also a file. A network socket, a file. Even a running process or your system's RAM information, yep, that's a file. This unified approach simplifies interaction with hardware and system resources. Developers and scripts don't need a bunch of different APIs to work with devices or configurations. They just read from or write to files. It also makes automation, scripting, and debugging much easier because the same tools you use to inspect or manipulate regular files can also be used for devices and system interfaces. This is one of the reasons Linux is so powerful and so widely adopted. Okay, so if Linux is just a kernel, why are there so many versions? That's where distributions come in. A distribution, or distro, is the kernel bundled with system tools, package managers, libraries, sometimes a desktop environment. Some are designed for servers, some for desktops, and some for minimal containers. A few examples would be Ubuntu, which is great for beginners and widely used in cloud environments. It has a tremendous community. Debian, which focuses on stability. Red Hat, which is considered an enterprise-grade operating system, used in production mostly. Alpine, which is minimalist and ideal for containers. They may differ in tooling, philosophy, or package systems, but deep down, they are all Linux. Every distribution has a package manager to install, update, and remove software. Ubuntu and Debian both use apt. Red Hat uses yum or DNF, and Alpine uses APK. Package managers are how Linux stays modular and lean. They fetch binaries and dependencies from online repositories. But why are there multiple package managers? It all comes down to the history and philosophy of each distribution. Each distro has its own approach to packaging, dependency resolution, and system maintenance. For example, Debian-based distros use apt system for robust dependency handling and ease of use. Red Hat-based distros use yum or DNF for enterprise-grade package control. And Alpine Linux uses APK as it is optimized for minimalism and performance, which is ideal for containers. This diversity lets users and organizations choose the system that best fits their use case, whether it's speed, stability, simplicity, or fine-grained control. As a DevOps engineer, you'll eventually work with more than one of the systems. Understanding their differences helps you adapt to any environment. Let's quickly recap what we've covered today. A short history of Linux and how it came to be. How Linux is used in the modern world. What an operating system is and how the Linux kernel fits into that. The difference between kernel space and user space. How the Linux file system is organized and why everything is a file. What distributions are and how they differ. What package managers do and why they matter. You don't need to memorize everything right now, just understand the big picture. In the next video, we'll look at what happens when a Linux machine boots up, from power on to a working login screen. BIOS, grub, the kernel, init systems, we'll break it all down step by step. If you found this video helpful, hit like and subscribe. Thanks for watching, see you in the next one.